going to look at how to draw simple Lewis structures. For this, we're going to need two pieces of information. We're going to need to know how many valence electrons an atom has, and we're going to need to know how many bonds it will tend to form based on that number of valence electrons. And we're only going to be looking at simple Lewis structures for molecules. We're only going to be talking about covalent bonding here. So I've kind of put a periodic table here, but cut out groups 2 through 12 because we're only going to focus on our non-metals right now, which include the right side, to the right of this bold staircase, and also don't forget hydrogen. So let's talk about valence electrons. You should be able to look at the group something's in and be able to figure out how many valence electrons. So group 18, our noble gases, all have 8 valence electrons, except for helium, which has 2. It still has a full valence shell, though, because there's only 2 electrons that can fit in the first shell. Now, 8 valence electrons is a special number. It is called an octet of valence electrons, and that's what all atoms, or most atoms I should say, the ones that we're going to look at, are all tending to try to get toward. It's energetically stable. So other atoms are trying to bond in order to get to 8 valence electrons. We had looked at ions in the past where they might gain or lose electrons to reach 8. And now in our molecules, they're going to be sharing electrons to get to 8 valence electrons. So since our noble gases already have 8 valence electrons except for helium, which has 2, there's no need for them to form bonds. We really don't find these noble gases in molecules much. And if we look at their electron dot diagram of just the atom, so here's neon, it's a noble gas, it would have 8 valence electrons. Notice that the entire Lewis dot diagram is filled. There's no need for bonds to get to 8 valence electrons because it already has 8. Let's consider our next group, the halogens next to it, group 17. They're one short of the noble gases. They have 7 valence electrons. So how many bonds are they going to want to form? They need 1 more valence electron to get to 8, so they're going to form 1 bond. Each bond is going to give it an additional electron that it's sharing from another atom. So if I kind of visualize this, fluorine bonded would look something like this. Each bond consists of 2 electrons, one that it owns, and the other electrons coming from the other atom this is bonded to. So there's an H over there or something, it would be coming from the H. So even though each bond does consist of a pair or 2 electrons, this fluorine would only own one of them. So if I'm kind of counting this fluorine would own 1, 2, 3, 4, 5, 6, 7, which is exactly what it should. And it's sharing 1 more to get to 8. So it's as if there's an octet if I'm counting how many are shared. So this still works out by giving 1 bond. It still owns 7, but sharing enough to get to 8. So notice how each bond gives it an additional electron that's coming from a different atom. So that's how you can figure out. You can kind of count how far away it is from the noble gases. This is 1 away from the noble gases, 1's 1 bond. Let's do it with the oxygen group, group 16. This has 6 valence electrons. It needs 2 more to get to the noble gases to get to 8, so it's going to form 2 bonds. And if I visualize this, and as long as these are single bonds, it could be 1 double bond instead, but I'm showing 2 single here. This oxygen would own 1, 2, 3, 4, 5, 6 that it would own, which is what it has here, and it would be sharing another one in each of these bonds in order to get to like an octet or 8 valence electrons. So I'm not changing how many it owns, that still obeys. I'm just it's just sharing another one in each bond from the atom next to it. So this is 1, 2, 3 away, so nitrogen group has 5 valence electrons and will form 3 bonds. So it might look something like this. Nitrogen would still own 1, 2, and it would own 1 from each of these bonds, 1, 2, 3, 4, 5, so it would still own 5, but each of these bonds is going to give it an additional electron that it shares from another atom, so it's as if there's 2, 4, 6, 8 electrons around it, and it's now obeying the octet rule. And finally, carbon is 1, 2, 3, 4 away from it. It has 4 valence electrons and would form 4 bonds, so it would look something like this. Okay, 2, 4, 6, 8 electrons are around it, so it's as if it has an octet, but it still only owns 1, 2, 3, 4 of those electrons. And don't forget hydrogen over here is still a nonmetal. It has 1 valence electron and it would form 1 bond. So hydrogen might look something like this. Hydrogen will never have extra dots because it only owns 1 electron. So we're going to be using this information to draw. First, we're going to try to meet these bond amounts. And then we'll add in extra dots, enough to make sure that it owns the correct amounts that we see up here. If I'm showing fluorine, I want to make sure it owns 7. If I'm showing oxygen, I want to make sure it owns 6, and so on and so forth. So this is the step-by-step that we're going to be using, and I'm going to do this in the midst of an example, but we're going to look up the bond amount based on our periodic table. Whatever atoms forms the most bonds, we're going to put in the middle, and we'll start with single bonds, and then we'll add any more bonds we need to make sure we reach those bond amounts that we set. Do not move on to dots until you finish your bonds. Then you can add enough dots to anything other than H. H never needs extra dots, to make sure that each atom owns the correct number based on their group. And as a double check, you can feel free to count the total electrons. I'll show you how to do that, or you can even calculate formal charges. So let's do use CO2 as an example. Look up the bond amount for each atom. So if I look up carbon, using my periodic table, and I'm just going to go back for a moment, carbon is in group 14, 1, 2, 3, 4, so it's going to try to have 4 bonds, and oxygen's in group 16, 1, 2, it's going to try to have 6 bonds, okay? So that's where we're going to start. 4 bonds, 2 bonds. Put the atom that forms the most bonds in the middle. It makes sense, it can connect to the most things. Like if you were building something, you'd put whatever could connect to the most things in the middle. And to keep it in the middle, put O's around it. And right now I don't care how you orient your O's, as long as there's one on each side of the carbon, because the carbon has to be in the middle. And start by single bonds, so we'll just draw one line, one line. Okay, now we need to make sure that these bond amounts are met first. So before moving on, I got to make sure that carbon has 4 and oxygen has 2. Wait a minute, that's not the case. Carbon only has 2 and each oxygen has 1. So what can I do? I can add more bonds. So if I add more bonds here, right, like right now carbon only owns 1, 2. But I need to add more, and now I've brought down what we would call formal charge of carbon to 0. It owns just as many as it should, and I've met these bond amounts. So again, I always have to meet these bond amounts first. Carbon has 4, oxygen has 2, check, let's move on. So now that I've reached my bond amounts, I want to make sure I add dots to atoms other than H, these are not H's, to make sure each atom owns the correct number of valence electrons based on their group. So if I kind of, again, go back to my periodic table. Carbon should own 4 valence electrons. It's going to be bonding so that it shares enough to get to 8, but it should still only own 4. And oxygen still should only own 6. So again, remember I said these are going to be the 2 numbers I use in my structure in drawing. Okay, so if I look at this, carbon should own 4, and in each of these bonds it does own 4. 1, 2, 3, 4. Each bond it owns 1, the other electron would be coming from the other atom. And each oxygen should own 6, but right now each oxygen only owns 2. 1, 2. So each oxygen would need 4 dots. And if I think about this in terms of formal charge, without the dots, oxygen would only own 2, it should own 6, so it would have a +4 formal charge, which is not good. If we add in the dots, now it owns just as many as it should. And it's bonding enough so that it's as if there's an octet around all of these. Oxygen 2, 4, 6, 8. Oh, it's sharing enough to get to an octet. Carbon 2, 4, 6, 8. Oxygen 2, 4, 6, 8. But I haven't changed the amounts they actually own. So this is a great structure. As a note, some people, instead of drawing lines, like to draw 2 dots for each line. So I could draw my double bonds like this. And if I look at it this way, it might even be easier to see what's being owned and what's being shared. So I'm going to color oxygen's red and carbon's blue. So each oxygen still owns 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And each carbon owns 1, 2, 3, 4. But because these electrons in the middle are, all shared between the 2 atoms around it, it's as if this oxygen is 2, 4, 6, 8. This oxygen 2, 4, 6, 8. This carbon 2, 4, 6, 8. Which is pretty cool. As a double check, feel free to count the number of valence electrons that should be there. So if I look at CO2, right, there's 1 carbon, and if I looked at the periodic table, it should have 4 valence electrons. So that's 4 valence electrons total for carbon. And if I look at oxygen, there's 2 oxygens. Each of them should have 6. 2 times 6 is 12. 12 plus 4 gives me 16. So I should have 16 electrons total in this structure. 2, 4, 6, 8, 10, 12, 14, 16. good. Now, what's great about formal charge is you could also use it to evaluate a structure you've already drawn. So maybe you drew something like one of these, and you could see, well, why are these not correct? If I look at this carbon, it should own 4, and it owns 1, 2, 3, 4, 5, 6. That's not good. Oxygen should own 6, and it owns 1, 2, 3, 4, 5. That's not good. Same down here. Oxygen should own 6, 1, 2, 3, 4, 5. Nope. Okay, and this carbon doesn't even have an octet, 2, 4, 6. So when you're done drawing a structure, evaluate, because you might need to redraw. Okay. When adding lone electrons, make sure they're added in pairs. So I don't really care so much where you put the pairs on the extra atoms, but make sure you put them 2 together, in pairs, not a lone dot. And you'll notice that for outside atoms, like if you have a single bond, you're typically going to be drawing 6 dots to complete the octet. 2, 4, 6, 8. If you have a double bond, you'll be drawing 4 dots, 2, 4, 6, 8 to complete the octet. And for a triple bond, 2, 4, 6 are already there, so 2 more to get to 8. And you'll notice on all of these, the formal charges would end up being 0. Fluorine should own 7, and here it does own 1 in this bond. 2, 3, 4, 5, 6, 7. Oxygen should own 6, and it does own 6. 1, 2, 3, 4, and 1 from each bond, 5, 6. And same with nitrogen. Okay. Why don't you try some examples? Feel free to pause the video and then unpause to check your work. So if we're going through this, NH3, N, if I look it up, it should have 3 bonds. H should have 1. So N will go in the middle, and we'll start with all single bonds. N, 1, 2, 3, perfect. H, 1 and 1 and 1, awesome. So I've met my bond amount. Now I just got to check if I need extra dots. To figure out how many dots I draw, that's where I'm checking how many valence electrons each atom should have. So hydrogen should own 1, and it does own 1, because in one of the, in this bond, there's 2 electrons, 1 coming from the hydrogen, 1 coming from the nitrogen. So each bond I'm counting as 1 electron it actually owns, the other is shared. And nitrogen should own 5. It has 1, 2, 3 already, so if I put a pair, an extra 2 dots, now it owns 5. And it's bonding enough to have an octet, as if there's 8 around it. 2, 4, 6, 8. See how that makes sense? It still only owns 5, but it's bonding enough to have an octet in what it's sharing. Okay, CH4, put the C in the middle. Put the H's around it, start with single bonds. C should have 4 bonds, that's great, and each H has 1. There's no need for extra dots because carbon owns 1, 2, 3, 4, no need for extra dots, and each hydrogen owns 1. C2H6, put the C's in the middle, and to keep them in the middle is put all the H's around them and start with single bonds. C wants 4, 1, 2, 3, 4 bonds. And the same with this one, and each H wants 1. Check if you need dots. Carbon owns 4, it should own 4 valence electrons, so no need for extra dots. C2H4, put the C's in the middle, start with single bonds. Make sure your bond amounts are met before moving on. Do not add dots until the bond amounts are met. Carbon wants 4 bonds. We only have 1, 2, 3. So we've got to add more bonds. I'm not done. I can't move on to dots yet. However, hydrogen only wants 1 bond, so I don't want to change any of these. So I can add, though, a double bond. I can add 1 more bond between the carbons, and now they each have 4 bonds. Hydrogen each has 1. Perfect. Okay, CH3Cl. C forms 4 bonds, H1Cl1. So we'll put the C in the middle. To keep it in the middle, put everything around it. I don't care how you put them. And start with single bonds. And now C does have 4, Cl has 1, each H has 1. I've met the bond amounts, move on to dots. I put enough dots so that each atom owns the correct amount. Carbon should own 4, 1, 2, 3, 4, perfect. Sharing enough to get to 8, but it only owns 4. Hydrogen should own 1, perfect. Cl should own 7. Oh, wait a minute, it only owns 1. So I need to put 6 dots around it. Now it owns 7, 1, 2, 3, 4, 5, 6, 7. HCN, H forms 1 bond, C forms 4, N forms 3, so C will go in the middle. Start with single bonds. H only wants 1 bond, so this is good, but carbon wants 4 and nitrogen wants 3. Don't move on to dots until the bond amounts are met. So I've got to add more lines. I don't want to change anything here because hydrogen still only wants 1, so I can add more bonds here. I could start with a double. Wait, C now only has 3, N has 2. I got to keep going. Make this a triple bond. Now C has 4 bonds, N has 3, H has 1. The bond amounts are met. Now we move on to dots. To put our dots, we figure out how many electrons should each of these atoms own. If they don't own the right amount, let's add more as dots. So carbon should own 4, 1, 2, 3, 4. It owns 1 in each of those bonds. The other is coming from the other atom. Hydrogen owns 1, so those are good. Nitrogen owns 1, 2, 3. It should own 5 according to where it is on the periodic table, so let's add 2 more dots. So now it's nitrogen owns 5, 1, 2, 3, 4, 5, but it is sharing enough to get to 8. 2, 4, 6, 8. And that's why it was bonding. CS2, C forms 4 bonds, S forms 2 bonds, so let's put the C in the middle since it can connect to the most things. Start with single bonds. I have not met the bond amounts yet. C wants 4, S wants 2, so I need double bonds. Now that I've met the bond amounts, let's move on to dots. Carbon should own 4 valence electrons, 1, 2, 3, 4, perfect. Sulfur should own 6, 1, 2, okay, so I need 4 dots, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. It owns 6, it's sharing enough to get to 8. OCl2, O forms 2 bonds, Cl forms 1, so let's put the O in the middle since it forms the most, and I don't care how you arrange your Cl's right now. Start with single bonds. Now O has 2, Cl has 1, perfect, bond amounts are met. Let's move on to dots. For dots, we need to make sure each atom owns the correct amount, so O should own 6, right now it owns 2, and each chlorine should own 7, right now it owns 1. So the O needs 4 dots, 1, 2, 3, 4, 5, 6 it owns, it's sharing enough to get to 8, 2, 4, 6, 8. And Cl should own 7, 1, 2, 3, 4, 5, 6, 7. In the bonding, it has the octet, 2, 4, 6, 8. Okay. H2CO. H forms 1 bond, C forms 4, O forms 2. C forms the most, let's put the C in the middle, keep it in the middle, put the other things around it. Start with single bonds. H wants 1 bond, we don't want to change those, but O wants 2 and C wants 4, so let's put a double bond there. Now our bond amounts are met, we can move on to dots. Do not move on to dots until your bond amounts are met. Now, carbon owns 1, 2, 3, 4, don't need any dots, never need dots on H. O owns 2, so we need 4 dots so that we can get it to owning 6 valence electrons as it should, as it's in group 16. N2, there's only 2 N's, so let's just put them in a line, and it needs 3 bonds, so I can't just do 1 line, I need 3 lines. Once the bond amounts are met, now I move on to dots. It should have 5 that it owns. 1, 2, 3 is only shown for each N, so I need 2 dots on each N. Now it owns 1, 2, 3, 4, 5, but it's sharing enough to get to 8. 2, 4, 6, 8, if I include the one it shares, not just the ones it owns. F2, 2 F's, so just start by putting 2 F's next to each other. Start with a single bond. F wants only 1 bond, so we're done with bonds. Now we move on to dots. So it only owns 1 for each F. They need to own 7, so we need 6 dots on each. 2, 4, 6, 8 is now what's like around it, including the ones it shares, but each F only owns 7, which is what we want. O, put 2 O's next to each other. Each O should have 2 bonds, so we can't just put 1 line, we need 2 lines. Once the bond amount is met, we'll move on to dots. 1, 2 electrons each O owns, so it needs to get enough to own 6, so each needs 4 dots. 2, 4, 6, 8 is what it's sharing. Each O only owns 1, 2, 3, 4, 5. So if I'm counting how many it owns, I'm counting each bond as 1. If I'm counting how many including what it's sharing, that's when I can count each bond as 2. I hope you enjoyed this. Stay tuned for more.